Okay, this is our last hint of Unit 1. So this is the Unit 1 learning packet, and we're in Part 3. And Part 3 is all about dilutions. Diluting concentrated solutions, making them dilute. And the equation is M1 V1 equals M2 V2. Now remember that molarity always is in the same unit, but the volume can be in milliliters as long as you know that it needs to be milliliters on this side. It can be in liters here. It can be in liters here. That actually can be in anything. You can have it in centimeters cubed or ounces as long as what goes in is the same thing as what comes out. And when we're dealing with this equation, this left side is usually referring to the concentrated solution, and this right side, the dilute solution. And when we're doing these calculations, what we really want to do is find out how much V1, and that's going to be represented by M2 over V2 divided by M1, is needed. So we need to take a little volume of the concentrated solution and then dilute it down to a final volume of V2 to make the dilute solution. And once we find V1, just like preparing solutions, diluting solutions have some rules, and I'm going to write those over here on this side because there's two different types. One for non-acids, so we're talking about ionic compounds or covalent compounds, alcohols, etc. here. So like before, we're always going to put on goggles and gloves. And then we're going to use a pipette to obtain V1. Okay, we don't know what that is. You're actually going to have some value here in milliliters. It's going to be some number of milliliters here of something. Okay, so V1, you're going to obtain, let's say, 10 milliliters of concentrated copper 2 chloride. So I'm going to leave this blank. In your learning packets, please do not leave it blank. And then you're going to add it to an empty Erlenmeyer flask. We saw the Erlenmeyer flask in part 1. It's that oblong shaped flask, kind of looks like this. Good for creating solutions. Now, this step is the step that's going to be different when we're dealing with acids. Okay, we're going to go back to this word empty in a second. And after we do that, just like with preparing solutions, we're going to add enough water or enough DI or distilled water to not add V2, but to reach a final volume of V2. Now, when you're doing the acids, the major difference is you do not want this Erlenmeyer flask here to be empty. You want there to be a little water, okay? Add H2O to the flask. And this is a big point before step number 2. Remember, that addition of water to acid, that's an exothermic process. So you want there to be a tiny amount of H2O in the flask already so that it can absorb the exothermic addition of the acid to the water. So that's a major, major difference. So this is going to be a key thing throughout the year, how to treat acids and non-acids during